Hi, very welcome to the Tech Zone. My name is David. This is the MSI Prestige 14 that have the latest 6-core i7-10710U processor and a dedicated GTX 1650 Maq-Q GPU. That configuration in a thin chassis like this will cause problems with overheating, and in this video I'll try to solve that by applying Thermal Grizzly Conductonaut. This is a liquid metal compound, and I'm doing this for the first time in my life. I hope that you can give me comments down below if I'm not doing it correctly, and please subscribe and give the video a thumbs up if you found this video useful. I will use this ArtiClean to remove the old thermal compound. First the remover and then the purifier, so we get a completely clean surface on the GPU and CPU. So this is the Thermal Grizzly Conductonaut, and what's special is that it is made of liquid metal, and leaving any stuff on the motherboard can result in short circuit. The thermal conductivity is 73 watt per meter Kelvin, and what comes closest to this is Thermal Grizzly Conductonaut at 12 watt per meter Kelvin. That is heat dissipation. And if you have suggestions on other compounds that are in this category, please leave that in the comment section below. And I need some paper to clean, and I use iFixit toolbox to remove screws, and there are also some other like these plectrums that I use for opening up this device. And iFixit has this tools kit is very useful. I have used it on many occasions, and it's really worth the money. Please check it out if you are interested in open up this kind of device. So this is the plectrums, very good for opening up a device like this. And here on the back side you can see there are 7 screws, and the middle screw is often covered by a sticker that says factory sealed or something. But that is not a warranty breaker to open it up, not at least in the Nordic region. So it's Phillips heads that I use for unscrewing. Not there are several other screws but this is very simple. So let's start up, open it up, and see how it looks on the inside. So starting in the upper left corner is the easiest for me, at least. So you just have to get it under the metal sheet on the back, and then it's just to work your way around. And then it comes off very easy. You can see it's a very thin metal plate, and you can also see the cooling small holes in the bottom chassis. Here you have to disconnect this the power, the battery power. It's just to flip it up, and then we have 2 screws on the fan itself, and you may have to move the cable a little to not break anything. So I just move it a little so it's easier to open it up. So we have 3 screws on the GPU and 3 other screws on the CPU. The GPU is the one on the left, and the CPU is the one that has the longest distance to the fan. And that long distance and the fact that it is only one fan is the real problem with this device. Optimum would have been 2 fans, and one for each, one for the CPU and one for the GPU. But unfortunately they don't seem to have space for that solution in this chassis. So I will fast forward this because it's quite boring to look at. They're easy to take away, and you have to be a bit careful when you lift it up so you don't bend anything, because that can cause problems when you are reassembling the system. Just jiggle a little bit and it will come loose. And here you can see the old thermal compound. And we're going to remove all that before we are proceeding. So, starting to remove the old thermal compound, I will use this Arctic Clean remover first. And I will fast forward this because this is very boring to look at. So be very careful and do this very thorough, so you have perfectly clean surfaces. And that also goes for the heat pipes and the heat plates that goes above the CPU and GPU. And now you can see this is the surface. It has some marks there, but I don't know what. And I'm not totally sure that this is copper all the way through, because if it's aluminium, then you have problem, because liquid metal can eat that away in just a few days. So what I will do, I will reopen this device and check if the thermal, if this liquid metal has done any damage on the surfaces. And this is the tape I will use, because this is a good tape, and it can stand up to 105 degrees Celsius, I think. And that if you are going to leave it on the motherboard for long, then you will need a very good electric tape. So I'm going to set that around both the CPU and GPU and try to cover the area on the die, and also a little bit on the circuits around the CPU and GPU. So this is also takes some time, so I will fast forward. So you need to be very careful when masking this the GPU, because you can see there are pins that are sticking up just around the surface of the CPU, and you need to have it really tight around that area, because otherwise you will end up with a short circuit if the liquid metal is moving. And since it is a laptop, when you're putting it in your backpack and so on, it almost certainly will be in vertical position, and that can maybe be a problem. But if you do this very thorough, then I think it will be good. So that was the GPU, and the same thing goes for the CPU. So open up the Conductonaut and check what's inside the box. A bit hard to open up this bag. It's hard to get a good grip. So we have some documentation inside. and we also have this is the thermal compound in this injection tool, and we have a warning. You can see aluminum or aluminium is not good with this thermal compound, and you can also see how it's supposed to be applied. I will apply mine in another way, because I think it's better to spread it out in a very, very thin layer. So that you have also a sort of a Q-tip and some different what do you call it, things to put on the injection tool to have more or less of the thermal compound. It also comes with a cleaning cloth, so I will also use that to be sure that all the surfaces are good and clean. So just minimizing everything that can cause a problem. So in the next step I will also use this to put the liquid metal in, not spraying it directly on the CPU and GPU. So you can see here I had to redo the GPU because it wasn't as good as I wanted. So now for the CPU, and I will cover that also fast with fast forwarding the video. So you see the whole die is a little bit elevated, so I suggest you don't put any tape on the top portion. You have no connectors there anyway, so you can put it directly on the motherboard. And it takes some time to do this, but it's important to do it very, very, very carefully and not cause any problems. So more or less done, just a little bit on the right lower corner, and I think we will be good to go here with applying the thermal compound. So just putting a little drop on the cap and see if we can apply this. This is maybe too little to start with, but it's better to start with little and take more after a while. It may be better to do just put a very, very little drop in the middle and let the pressure distribute the liquid metal. This takes some time. I will just fast forward this section also. So I suggest you take your time, no rush. Let it take several hours if it had to, because it's very important that you have a thin layer and not so much that it can be pressed out when you put on the heat pipes and press them against the CPU and GPU. You don't want it to come away from the surface. You need to have all the liquid metal just on the CPU surface and the GPU surfaces. So I'm putting a little bit more tape to cover as much as possible. Remember, when you work with this, don't hold anything above the motherboard when you are going to eject the metal, liquid metal, because it's so easy that it just sprays away and you get it all over the motherboard, and it's very hard to remove, in my opinion. I had some issues with that. not that it came on the motherboard directly, but it was a little bit around the CPU and GPU surfaces. So it's starting to look good. And the next step is to put liquid metal also on the metal plates. This is how it looks more close up. You can see there's a little bit too much here on the GPU, I think so, at least. So I will have to spread it a little bit better. So you understand it takes some time. I think totally I maybe it took 1 hour or 1.5 hours. So just spreading it with a Q-tip, and I think it's easy. In the bag it was an Q-tip, special Q-tip from the manufacturer of the Thermal Grizzly. But I find it more easy to distribute it with a standard Q-tip. So now it looks fine. So quite good, I think. The first time I tried this, I put it together without applying anything on the heat plates. But when I opened up and checked how it looked, I couldn't see that the two surfaces had been in contact. So therefore I'm reapplying and putting on some thermal paste on these plates also. And that will probably be better. So when this is done, it's just to reassemble the system and power it up. And be careful and try to remove everything that is on the sides, and so you don't get any liquid metal moving from these plates to the motherboard. So yeah, now it's just to reassemble and power the system up and see if it works. I can assure you I'm pretty nervous about this. Powering it up, first I thought the system was dead, but you can't just power it up with that button. You have to put in the charger first. I thought I opened it up and checked to see if I have left some liquid metal on the motherboard or something, because it was terrifying. But you can see now it responds, and the screen is very, very dirty. I'm sorry for that. So booting it up, it takes some time, so this is a fast forward as you can see. But when done, it's yeah, just starting, and I will directly do a 3D Mark test and see if we have improved the system anything. So just starting up the 3D Mark, and we're going to run TimeSpy that has a takes very much CPU power in the CPU test, and that causes high temperatures. So just fast forward to the results. We'll also try to do gaming tests and see if the temperatures have improved in games like Far Cry 5 or something else that is quite demanding, where I earlier had temperatures over 92-93 degrees. So you can see 3071 point is very good in this, the combination of this 10th gen CPU and the GPU. And you can see it still gets hot. Not as hot in the first two tests, but on the CPU test, then you can see it's still around 92 degrees. But see at the frequency line, it's almost totally straight. It's just some minor dips in the end. And that must mean that the temperatures has been under control all the way to the middle of the CPU test. And that also corresponds to the 92 degrees. So here we have the results from the stock thermal compound. And comparing it with the liquid metal, you can see that the GPU utilization is 100% on liquid metal and 99% on stock thermal compound. The CPU, on the other hand, tends to approach 80 degrees more often than on stock thermal compound, and is around 5 degrees cooler on liquid metal. The temperature on the CPU test max out at 93 degrees on liquid metal and 95 degrees on stock compound. That's only 2 degrees difference. But it's not often you run this kind of heavy computing. Maybe if you are working in MATLAB or some other application that demands more from the CPU than the GPU, then it can of course be a problem when running long calculations that takes hours. So that can really damage the CPU. So that was all for this time. If you have questions or comments, please leave them in the comment section below. And yeah, that's all from me. Thank you very much for watching. Bye bye.